All right, so I'm going to continue on with number 14. So on this section, they want you to find the equation in vertex form, given a point on the parabola and the vertex of the parabola. So remember, vertex form is ax minus h squared plus k. So the good news is they're giving you the vertex, so they're totally giving you the h and the k. The only thing you have left to find is the a value. So we're going to use the xy point to then calculate the a. So here we go. So remember, the vertex is the hk and the point is the xy. So I'm literally going to I'm going to go ahead and write it again. Ax minus h squared plus k, right? We're going to take, I'm going to kind of color code this. I'm going to take the h value and plug it in for h. I'm going to take the k value and plug it in for k. I'm going to take the x value and plug it in for x. I'll go with pink. And then we're going to take the y value and plug it in for y. And that's basically a number for every single thing except for the a. So it's going to allow us to solve the equation for a. All right, so here we go. So let's see, the y value is 26. The a is what we're looking to find. The x is negative 12. The h is negative 4, but you're putting that behind a minus sign, so it's going to turn into plus 4 squared, and then plus 2. So we're going to use this equation, and we're just going to clean it up one step at a time. The first thing you want to do is you want to take care of, hold on, let me change that color. I'll use red. So you want to take care of this multiplier that's behind the a, right? And we're going to end up putting it in front of the a when we're all done. So negative 12 plus 4 is negative 8. And negative 8 squared is positive 64. So we're going to take that positive 64, right, whatever number you get for that mess. And because it's a multiplier, we're going to put it in front of the a, because it sounds really weird to say a64, right, when what we really mean is 64a. Right, so the 64 comes from this part right here, negative 8 squared, which is positive 64. And then I'm going to bring down my 26 and my plus 2. And then what do you know? We're down to a basic little two-step algebra equation. Sorry, don't mind my stuffiness. So we're going to subtract the 2. And that's going to give us 24 equals 64a. And then, of course, we're going to divide. We're going to divide by 64 on both sides to cancel out the 64. And that is going to give us a equals 2/3. And I totally take that back. That is not 2/3. Sorry, I was looking at a different question. That's 3/8. Sorry about that. So we can just type that in our calculator and hit math, enter, sorry. Right, and we can reduce by 8 on the top and the bottom, which is where we get 3/8. So that's our a value. And now we have everything we need, because the only three things we need to write something in vertex form is an a, h, and a k. So we have all that information now. So now we're going to write our answer as y equals the a, which is 3/8, and then x plus 4 squared plus 2. There you have it. And you can, of course, check your answer in Desmos by typing in this function right here that we just wrote down, and then making sure that the point negative 12, 26 is on the parabola somewhere, and that the vertex is at negative 4, 2. All right, so you should be able to check pretty much every answer, right, on this review with your Desmos. Okay, I'm just going to run and do this one really quick. I'm not going to do all the highlighting, right? But this one gives us the point first. And remember, the point is the xy, and the vertex is the hk. So again, we're just going to throw everything into that vertex form. So y equals, so 3 equals a, which is what we're looking for, x minus h squared plus k, so plus 5. And then you're going to do the exact same thing we just did on the last problem, right? You're going to take this 2 minus 3 squared, and whatever you get for that, you're going to put that multiplier in front of the a. Right? So 2 minus 3 is negative 1. Negative 1 squared is positive 1. Right? So we're just basically going to rewrite this as 1a, or just a. If you want to put the 1 in front, you totally can. Right? And so, of course, we're solving the equation for a. So we're going to subtract the 5 from both sides, which is going to leave us with negative 2 equals a, or 1a. And yay, that gives us the a value. So we're just going to take the a, and we're going to take the hk, and we're going to write the vertex form. So y equals negative 2x minus 3 squared plus 5. And that is our vertex form. Okay. All right. The next two questions are converting into standard form. So remember what standard form is. I'll write it in pink. Right, standard form is y equals ax squared plus bx plus c. So it doesn't have any parentheses in it. So that's kind of how you know, right? We need to get rid of the parentheses. And there's a little typo here. This should say f of, that needs to have a little parenthesis, which is basically the same thing as y. So if you want to change it to y equals, you're more than welcome to. All right, the whole point is, though, we have to get rid of these parentheses, and you have to follow PEMDAS rules, right? So the first thing you have to do is exponents come first, right? So we're going to get rid of the parentheses by applying the exponent. So remember, that means x minus 1 times x minus 1 when you're squaring the binomial. And you need to double distribute that, right, to get rid of the parentheses. So here we go. We're going to double distribute. Oops, sorry. All right, so x times x is x squared. And then we have x times negative 1, right, which is negative 1x. Then we have to distribute the negative 1 to everybody. That's so negative 1x again. And then we have negative 1 times negative 1, which is positive 1. And then we have our like terms here in the middle. So we end up getting the trinomial x squared minus 2x plus 1. Okay, but that's just the x minus 1 squared part. We still have, I'm going to put all that in parentheses, we still have a negative 4 multiplier, right, in front that needs to come down. And we have a plus 5 constant still hanging on the end. I'm just going to put y equals. All right, and so now we need to, let me move all this down a little bit. There we go. Now we need to distribute the negative 4 because we have another set of parentheses that needs to go away. So we need to distribute the negative 4, which is going to give us negative 4x squared, then plus 8x minus 4. And then I'm going to bring down my plus little 5 hanging on the end there still. And then you'll notice we have a pair of like terms, but now it's the constants at the back. So our final answer is y equals, or you can write f of x equals, it really doesn't matter to me, negative 4x squared plus 8x plus 1 is going to be our final answer in standard form. And again, there's absolutely no reason in the world to miss these questions because you can totally check this in Desmos, right? You're going to type in this parabola, then you're going to type in this parabola, and you should get the exact same parabola. They should just be laying on top of one another because they're the exact same parabola, exact same quadratic equation. They're just written in two different formats, okay? All right, I'm going to run through that process again over here. Same exact process. We've got to take care of the x plus 4 squared first and get rid of the exponents. So I'm going to do that first. So x plus 4 times itself, because that's what it means to square. And then you need to do all your double distributing, right? The x has to get distributed and the positive 4 has to get distributed. So that's going to give us x times x is x squared. X times 4 is 4x. Then when we distribute the 4, we get another 4x and 16. So we have our like terms in the middle, right? That combine to give us x squared plus 8x plus 16. But that's just the binomial, right? You still have to bring down the 1/2 multiplier that's in front of all of that, and then the minus 20. And now we need to distribute again, right? Because now we have another set of parentheses because of the 1/2 multiplier. So everybody inside the parentheses needs to get multiplied by 1/2. So that's going to give us 1/2 x squared. And half of 8 is 4. And half of 16 is 8. And then bring down the minus 20. And then again, you have constant like terms at the end that you can combine. And that should be your last step. So 1/2 x squared plus 4x and then minus 12 is going to finish that off. And there's our standard form quadratic. And again, totally check it in Desmos. Make sure it's the exact same parabola as your vertex one gives you. Okay. All right, moving along. We're into the solving part, right? So we have 4 methods of solving, right? So our first one was graphing. Please use Desmos for this. There's no reason why you shouldn't be using Desmos. That's the whole reason we're letting you use the graphing method. So I'm going to write that here. Use Desmos. Right? So literally just type this function into Desmos and then just look at the graph. Now you should be able to tell me what the vertex is, right? Because the vertex is HK, which is -2, 4. I also know the parabola opens down and has an A value of 1. But if you just literally graph it, right, down 2/4, right? I know this is what my parabola is going to look like. And again, use Desmos. If you need help with that, that's what Desmos is for in the graphing method. And of course, the solutions are the 2 x-intercepts of where it's crossing the x-axis there. Right, so you're just literally writing those down. So you should be writing your solutions as ordered pairs. So -4, 0 and 0, 0 are our 2 solutions. Okay. All right, next up is this guy right here on number 19. We have an issue though, because in order to put it into Desmos, or to solve it anyway, it needs to be set equal to 0. So this +4, he needs to come over here to join everybody else. And of course, the only way to move a +4 to the other side of the equation is to subtract it. So he's going to become negative when I put him over there. And I'm just literally going to go to Desmos. I'm going to type that in and I'm going to graph it. Right. So I believe the vertex is 1, -5. If you put that into Desmos, again, just use Desmos. Just click the button. It'll tell you where the vertex is. And then it crosses the x-axis like somewhere like here-ish. It's not a pretty number, but that's okay. And then his little reflection buddy is like over here somewhere. Right? So again, I'm going to graph a decent enough parabola. Right? And my solution is these 2 x-intercepts. Now, even if I didn't have Desmos, then I wouldn't use the graphing method for this clearly, right? I'd be using the quadratic formula because this is obviously not a pretty answer. It's going to have these infinite decimals, but we have Desmos, so just use those to your advantage, right? I'm just going to click on the button and click on the or the x-intercepts, and I'm going to get about -1.23 and +3.24. And I'm just going to write those as ordered pairs. And voila, graphing method. Again, use Desmos. If you want to do it by hand and do the -b/2a and all that stuff, you're more than welcome to, but you should be checking it in Desmos, right? To just make sure you don't make a silly mistake. All right. The next one is solving by factoring. Okay, so again, it must be set equal to 0, and then you're just going to factor it. Okay, So here we go. Obviously, this guy is not set equal to 0. We need to subtract that 4x over. And we need to make sure we put it in the middle, right? Because we need it in ax squared plus bx plus c form. And then this is the trinomial that we need to be factoring. Let me scooch that down a little bit. So we're right back to unit 6 here, right? We need to multiply the a times the c so we can create our little number puzzle. Right, so off to the side. Again, you can just do this in your head if you want to. I'm looking for the only two numbers in the universe that multiply to give me negative 12, but combine to give me negative 4. And it looks like our winners there are going to be negative 6 and positive 2. Right, to multiply to give us negative 12, but add to give us negative 4. So that means, excuse me, sorry. I'm going to bring down my first term, and then I'm going to split my negative 4x into negative 6x plus 2x. Then bring down my constant. And then we're going to factor by grouping, right? So we're going to split this down the middle and then do GCF 3 times in a row. So it looks like our first two terms have a 3x in common, which will leave us x minus 2. And then our second two terms have a positive 2 in common, which leaves us with x minus 2. So now we can take out the x minus 2, and our other factor is the leftovers, 3x plus 2. Now, a lot of you guys stopped at this point on your quiz, but you're not done. You're done factoring, but you're not done solving, right? You have to get to x equals this and x equals this, right, and get two solutions. And we do that by taking each factor and individually setting each one of those parentheses equal to 0. And you don't need the parentheses anymore. You can drop the parentheses, right? We're literally just taking this factor and setting it equal to 0 and that factor and setting it equal to 0. And then you need to solve these little algebra equations. So obviously this little guy, we just have to add the 2 to the other side to get the x by itself. So x equals 2. And over here, this is a two-step algebra equation. So we're going to subtract the 2 first. And then we'll divide by 3. All right, so the 3's cancel. And we get x equals, oops, write that purple. We get x equals negative 2/3. And of course, I would love your solutions to be written as ordered pairs. So we would write our final answer as 2, 0 and negative 2/3, 0. Right, and that's going to be our final solutions. And again, you must show all of this work on your test. If it says to solve by factoring, every single one of these lines is going to be worth points. Okay, if you just go to Desmos and tell me the answer, I might give you 1 or 2 points, but you're going to be missing about 10. Right, so you have to be able to prove that you can actually solve by factoring. But let me just show you really quick. I'm going to go to Desmos. And I'm just going to type in my equation. Now, it does have to be the one that we set equal to 0. So 3x squared. We moved the 4x over and then minus 4. Right, so here's my parabola. And you can clearly see I can check that, right? 2, 0. And then the negative 0.666 repeating. That's negative 2/3, right? So I totally did my problem correctly and I got the right answer, but I got it through factoring versus using Desmos and graphing. Okay, but you want to take, that took me less than 5 seconds, right, to double check my math and make sure I didn't make any mistakes there. All right, number 21, we also want you to factor by, group, can't even talk. We want you to solve by factoring on this one. A couple of things to notice. Number 1, it's not in standard form. So I'm definitely going to flip it around. The x squared should be written first, and then the positive 9x should be written second. Clearly, there's no c value, which makes this a binomial. So not only did I need to flip the terms to get it in standard form, but I also want to recognize it's a binomial, and the only 2 ways that you can factor a binomial is if there's a GCF or if it's a difference of 2 squares, right? So first of all, you want to ask yourself, is this a difference of 2 squares? Clearly it's not. 6 and 9, or 6 and x, those are not perfect squares. It begins with a negative. That's gross. So this is definitely a GCF problem. And as you can clearly see, it begins with a negative, so I'm going to take that out. So I have a negative, and I have a 3 and an x in common, which is going to leave me with 2x minus 3 for my two factors. So all we did was factor out the GCF. I'm putting no here. There you go. And we're not done, of course, because we need to take each factor and set each of our factors equal to 0. So we're going to take negative 3x and set it equal to 0. And then we're going to take 2x minus 3 and set it equal to 0. And then we're going to solve these little algebra equations. Now, clearly this first one, the only thing I need to do is divide by negative 3 to get the x by itself. And of course, 0 divided by any number is going to give me 0. So 0, 0 is one of my solutions. And then, of course, this guy over here is a little two-stepper. So we're going to add the 3 first. So we're left with 2x equals 3. And then we're going to divide by 2 on both sides. Right, so we're going to end up with x equals 3 halves, or 1.5. It doesn't, I don't care which way you write it, because 3 divided by 2 is exactly 1.5. So it's a nice, pretty finite decimal, right? So you can either write your answer as 1.5 comma 0 or 3 halves comma 0. That is totally up to you. I'll take it either way. Desmos is, of course, going to give it to you as 1.5 when you're checking your answers, so just be aware of that. All right, and again, I'm just going to go ahead and show you. If I go to Desmos, let me take this one out. And you can even type in the original if you want to, right? But I'm going to go ahead and type in my negative 6x squared. Oops, hold on, I forgot my x. There we go. Oh my goodness gracious, that's a mess. There we go. Negative 6x squared plus 9x. You can see when I tap on them, I get 0 and 1.5. So yay. Right, very easy. Took less than 5 seconds to check that. All right, our next little section here is going to be simplifying each radical. All right, these are our factor trees, right? So remember, you got to have a buddy to leave the house. So here we go. I'm just going to start 28. You can break it down any way you want to, right? You can do 4 times 7. You can do 2 times 14. It does not matter as long as you find any two numbers that split up to multiply that gives you 28. I'm just going to use 4 times 7 and 7 is prime, so I'm going to go ahead and circle him. But 4 can be broken down into 2 times 2, which are both prime. So once you get done breaking it down all into its primes, please remember that once you break a number down, he's not actually there anymore. The only numbers we're looking at are the 2 times 2 times 7, right? That's how we get 28. And then you just ask yourself, what do I have a pair of? I have a pair of 2s, which means as far as the radical goes, we get to take out a 2 to represent the pair inside. And then this 7, he doesn't have a buddy, so he has to stay inside the radical. And that's our answer, right? Again, we're not solving anything. We're just taking something and simplifying. It's kind of like reducing 3/6 to 1/2, right? Like reducing a fraction. It's kind of that same deal, right? We're just simplifying our answer a little bit. All right, number 23. I'm just going to run through these pretty quick. So 600. I'm just going to do 6 and 100. And again, it doesn't matter how you break them up. We'll all end up with the same primes at the end. Now, if you want to, you can break the 100 into 10 and 10 and call yourself a pair and call it a day. I'm not going to do that just because I don't want to confuse anybody. So I'm just going to go ahead and break it down all to the primes. So I'll use 2 and 50. And then I'm going to use 2 and 25. And then 5 and 5. And now I've got all the primes, right? So here's my square root. Whatever numbers have pairs get to come out of the radical. So it looks like I have a pair. Oops, sorry, I meant to highlight that. Looks like I have a pair of 2s. So I get to take out a 2. Oops. And it also looks like I have a pair of 5s. So I get to take out a 5 as well. But then it looks like this 2 and 3, they don't buddy up. So they have to stay inside. And it doesn't matter whether you have multiple numbers on the inside or the outside. They just get multiplied back together. So that's going to give us 10 root 6 as our final simplified radical. All right, moving along. All right, so this one, notice this one already has a 3 multiplier on the outside. So when I'm simplifying the square root of 24, I already have a 3 multiplier on the outside. So if I'm able to take anything else out, it has to get multiplied by that 3 in the front there. Okay, so here we go, 24. It's a pretty small number. I'm just going to do 6 times 4, which is 2 times 3, and 2 times 2. Okay, oops. All right, so it looks like we have a pair of 2's, which means I get to take out a 2 to represent the pair, but then the other 2 times 3, they don't buddy up, so they have to stay inside, which is going to end up giving us 6 root 6. And that's our final simplified answer. Okay, and then last but not least, this guy over here, notice he already has a 5 multiplier in the front, right? So when I simplify my radical, right, I already have a 5 multiplier out there. So I'm just going to go ahead and get him set up for that. And then I'm just going to do this factor tree for 54, which is 9 times 6, 3 times 3, 2 times 3. And again, it doesn't matter how you break it up. Every single person is going to end up with 3 3s and a 2, no matter how you start that tree. Right? So everybody's going to notice, hey, I've got a pair of 3s. Right? So a 3 is going to be able to come out. And then the 2 and the 3, man, I don't know what it is about 2s and 3s on these examples. Right? The 2 and the 3 that don't buddy up have to stay inside. Okay? All right, so that's going to give us a final answer of 15 on the outside and square root of 6 left over on the inside. All right, and the whole reason we have to learn how to simplify square roots is so that we can solve by square roots. Okay, so here we go. I'm going to solve by square rooting. There's 2 types of problems, right? The problem that has the x squared that you need to isolate and just solve it like a normal algebra equation. And then this one over here, he also has just an x squared, but he's kind of a little bit different because the square is on the outside of the parentheses. So you're still going to solve these just like normal, everyday algebra equations, right? You're trying to solve for x and get the x by itself. Okay, so here we go. This one is pretty easy to get that x squared by itself, right? We're going to do the same moves that we would always do with solving an algebra equation. So we're going to subtract 2 from both sides. Right, and that's going to leave us with 3x squared equals 27. And we have to get the x squared by itself before we can do anything. So we've got to get rid of that 3 multiplier by dividing. Right, and that's going to give us x squared equals 9. And then you guys know the only way to get rid of a square is to square root, because those are inverse operations. So we're going to square root the 9. And luckily for us, right, square roots and squares cancel. That's how we get the x by itself. And the square root of 9 is a perfect square, so it's 3. But don't forget, quadratics have to have 2 solutions. So when you solve by square rooting, you are responsible for putting in the positive and the negative root of 9. Right? So you have to be plus or minus 3, which means our answers are going to be written as positive 3, 0 and negative 3, 0. Those are our 2 x-intercepts. Okay. All right, then the next one is very similar in that we're just going to solve it like a normal algebra equation, but we have to slowly work our way to get to that x because he's trapped inside a set of parentheses right now. So we want to move the constant first, like we always do. So we're going to add the 9. Always work from the outside in. The furthest away from the x to the closest away to the x. That didn't make much sense. X plus 1 squared equals 80. Right? Then we want to get rid of that 2 multiplier in the front. Right? So those cancel. So that leaves us with x plus 1 squared equals 40. And this is where it gets a little different than the previous problem, right? Because now I cannot get to that x without first eliminating the square. So instead of square rooting at the very, very end, like I did here on this problem, I have to square root now to get rid of the square so I can get to that x, right? So once I get rid of the square by square rooting, right? So square roots and squares cancel. Now I don't have a need for the parentheses anymore. So I can just drop the parentheses and write x plus 1. But then over here, I need to take the square root of 40. Now over here, I got the square root of 9, which is a nice perfect square. But the square root of 40 is not a nice perfect square, right? So that means you need to go off to the side and you need to simplify the square root of 40 like we just did on those previous 4 questions. Right? So if I simplify the square root of 40, everybody should get 3 2s and a 5. Right? Which means I definitely have a pair of 2s. So that means that it's 2 root, and then this 2 and 5 have to stay inside, so 10. But don't forget, plus or minus 2 root 10. Anytime you solve by square rooting, right, you've got to get the plus or minus in there. And we're almost done. We just have this positive 1 that needs to go to the other side. So I'm going to subtract 1. And guys, that should go in the front. I noticed a lot of you guys on your quiz, you put the -1 at the back, which is not wrong necessarily, but when you're working with square roots, the square root should always be the last thing in your answer so that it's not confusing as to where the square root stops. So when these cancel, I'm going to get x equals -1 plus or minus 2 root 10. You cannot do anything with those two terms because they're not like terms. The -1 is a constant, and the 2 root 10 is a root 10 number. And root 10s can only be added to other root 10s, right? So those are not like terms, so they cannot be combined. So your answer is just this gross-looking binomial. And I'm going to split that up, though, and write it as ordered pairs. -1 plus 2 root 10, comma 0, and -1 minus 2 root 10. All right, so one of my answers uses the positive, and one of the answers uses the negative in between. Okay, and those are my 2 solutions. And you could totally check that in Desmos, but it's kind of a pain for these because you would have to set these equal to 0, and, you know, it's just kind of a pain. So typically I would just trust my math there, but you can totally do that if you want to. All right, you'll notice on your review, you don't have a 28 and 29, so this is omitted, so we just took that off the review, so you shouldn't even see anything here. Right, but these were omitted. We will learn how to complete the square, but we don't have enough time to get to it before STAR test, and it's not tested on STAR, so we will talk about it after the STAR test. Okay, so we're going to skip those and hop right to quadratic formula. I'm actually going to stop here because it's a good breaking point to get to the final third of the review, so we'll pick back up here at number 30.